So that's good. All right, guys. So we are starting where we left off last time. And could you all comment your names, please? I've got 4 of you so far. So I'll wait for a couple more and then we'll do the register. And I'm pretty sure we were doing, or just about to do, these ones. I can't remember if I gave you guys much time to do them, actually. Let me just have a quick look while I wait for you guys to sign your names in. Cool. Okay. Didn't go for that. Did we skip to 12? Okay. I'm gonna skip 11. There it is. It's not hard. It just takes ages. Basically, you need to use your answer to part 10 to save 10 minutes of work. To do 11, I'll talk you through the method, but I don't want to do it. We basically need to keep whittling this down to cos 7. We can say it's cos squared cos 5. Turn that into sine. Then we go from cos 5 to cos squared cos 3. Change that into sine. Then change cos cubed into cos squared cos. Turn that into sine. And then you're going to have like sine to the something big, cos to the 1, and then you can use the recognition. But you've got like, I don't know, 6 or 7 terms of cosine, 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 cosine to expand, integrate all of them via recognition, and it basically looks like an expansion. And how you're meant to do this one really is with some sort of expansion. But yeah, you can do that, and that's kind of what you're doing in this example. You are expanding. But yeah, I don't want to do it because it'll take half the lesson, and that's the method. That's the trick to it, is changing it into cos squared times something else, and then change the cos squared into sine squared, multiply out the brackets, and just keep going until you end up with something to the power 1. And when you've got one of the trigs to the power 1, then you've got the derivative of the other function. Okay. So, I think you guys were the first group I showed this to, maybe. I can't really remember. But yeah, so I want to. The goal for today is just to get these 8 questions done. I'm going to give you guys some hints, but I would like you to try them all. Has anybody tried these yet? Because I know I put them up at the end of last lecture. I don't want anyone to just be like repeating themselves, but I can give you some better hints today. So I think we're going to start off just by looking at 13 and 14. We'll do them in little sets. So to start with 13, 14. 13, 14 shouldn't be too bad. The first one, we've got some double angle stuff. You're actually going to use it twice. And the second one is a recognition. So I'm going to give you guys 5 minutes to do those 2, and then we're going to move on to the more challenging ones. But those should be all right. With those hints, that should totally be doable. So 5 minutes, please comment your answers when you got them. and we'll go through these in a bit. And I'll do the register now while you guys do this. So, Joseph, Sid, Regan, Sam, Kezia, Dan, Frank, Samuel, Casper. Cool. So I don't have Will, Zach, Sam, Cornell, Lottie, Hannah, Carrie, Samuel, or Isaac. If any of you guys are here, either comment, or if you can't comment, send me a. Oh, sorry guys. Send me a message on Teams. Cool. Right. Yeah. So Dan and Kezia, good job with the first one there. So yeah, the key to this one, spotting that you've got for sine x cos x, which is basically, we can rewrite this as 2 cos x, 2 cos 2x. And then the other 2, because 2 times 2 is 4, sine x cos x. That is a double angle for sine. So we get integral of 2 cos 2x sine 2x. And then we can see we've got the double angle for sine again. So that is all the double angle for sine to get to sine 4x. So integrate that, sine integrates to minus cos, angle stays the same. We've got 2 out the front, we need to divide by the 4 to get 1/2. Yeah, and plus c. All right, second one is recognition. It's one of the more tricky recognition questions because you need to remember what cot differentiates to. Yeah, so cot differentiates to ln sine x. So for this one, we're going to try wait, sorry, what am I talking about? Cot integrates to ln sine x. So ln sine x, if you differentiate ln of sine x, you get sine differentiates to cos, comes up the top, you get 1 over x. So yeah, we're going to try ln of sine x all squared. Sorry, iPad's just frozen quickly. As soon as this loads, come on. Oops. All right, hang on. Let me check that. I did do that quite quickly. Now it's frozen again. Sorry, guys. It is possible. I might have messed up the second double angle. I'll go back to that and check. As soon as the iPad starts playing properly. There we go. All right. All right. So where were we? Integrating, was it sine 4x? Maybe I left the 2 in there, actually. I think that's what I might have done. Yeah, I left the 2 in. That was stupid. So yeah, it should go to minus a quarter cos. Cos with 2 c's. Minus a quarter cos for x. Yeah, I just left the extra 2 in. Sorry, guys. If you look back at that one, there was a mistake. Anyway, so this one, where was I? I was saying it was going to be ln sine x all squared, because we basically got this is f of x, the power 1. This is f dash x. So for that case, we try fx to the power 2. So I'm going to try this squared. Obviously, we don't want the 2 out the front, but it does differentiate. So this is that's your answer. So kind of by recognition there. All right. So those 2 weren't too bad once you know the methods. These do get progressively worse though. All right, so we've got 3 more here. These ones are starting now to get quite tricky. So the first one, I'll give you some hints still. The first one is going to be u equals ln x substitution. Second one is by parts. You got to use it twice. And the third one is substitution. I'll let you pick the precise substitute. Right, so I'm going to give you guys a bit longer for this one. I reckon probably 15 minutes for these. Let's go with 15. If you need longer, please say, because we've only got like 9 questions to do today. So we can spend a bit longer in these if we need to. But yeah, 15 minutes starts now. Hannah, I've just seen that. I'll swipe you in now. If you want to rewind, you can. We've done 2 questions so far. Or you can try these and rewind later. But I'm starting a timer now for 15 minutes. Give these a go. Cool. All right, let's go through them. So Dan, well done there. You think those are all correct. We will see. They look of the right form. We'll look at the individual terms in a second. So first one, I said use use u equals ln x. So du dx is going to be 1 over x. So dx is going to be x du. So the integral is going to turn into 1 plus u over xu x du. Those x's will cancel. So we get 1 plus u over u. We can turn that into 1 over u plus 1. 1 over u turns into ln u. 1 turns into u plus c. We'll put ln x back in, so we get ln of ln x plus ln x plus c, which you could use log rules on. So you could say it's ln of x ln x plus c using the log addition multiplication rule there. Cool. All right. Second one. I said by parts twice for this one. So the first bit's kind of easy. I'm going to cheat here because I've done this already, and I'm going to just I'm going to start with the second integral because I feel it might help. So I'm going to write that bit out. Here we're going to have u as ln x. So plus blah, 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 blah. U as ln x, v dash is going to be, sorry, ln x, ln squared x, isn't it? So I'm going to write that as ln of x, all squared. U dash will be 2 over x, ln x, and v will be x squared over 2. So the whole thing is going to turn into the integral x ln x plus uv minus v du dx. So that's going to turn into x squared times 2 over 2x ln x. And that's all going to cancel down to give us x ln x. Ooh, so this is interesting. So we've got the integral of x ln x plus this, which is done. That's a bit, that's a bit dodgy that I've written it like this. Really, I should put dx in here to kind of show that this isn't being integrated, but whatever. So you've got this, plus this, take away this. Now this is the same as this. So those two, we've got plus 1 integral, take away the same thing. They're going to cancel, leaving us with x squared over 2 ln squared x. Cool. Which you probably wouldn't spot unless you'd done it before. But yeah, there you go. And the last one, substitution again. So I'm going to make u equal to x. So du dx 1 over x. So so dx is x du. So we get the integral of ln u over x u times by x du. That x and that x are going to cancel, leaving me with ln u over u du. Now we could probably do this by parts, or you could use substitution again. I'm going to do it by parts. So the other two times I did this, I did it by substitution. So to do this by parts, I'm going to write it as the integral of u to the minus 1 ln u. So u is going to be ln x. V, or dv dx, v dash, let's call that. V dash is going to be u to the minus 1. U dash, 1 over x. V is the integral u to the minus 1, we're assuming u to the minus 2. So it's not. It's going to be and u. What am I talking about there? Oh yeah, you just do it by recognition. Sorry, that's probably the easiest way after all. Yeah, recognition probably is the nicest way there. Well done, Dan. I never spot recognition when it's of lens. Anyway, I'll keep going for this now I've started. So UV this isn't going to help. I'm talking rubbish. That was not a good method. That's what we're trying to do. Stan's done recognition, recognizing that this really is 1 over u ln u, which this is the derivative of that. So we can try ln u all squared. If you want to do it by substitution again, though, I could say p is ln u, dp by du, 1 over u. The du is u dp. Put that in, and I get p. P was ln u. And u was ln x. So we get ln x squared over 2 plus c. That's not very clear there, is it? Ln of ln x, put squared in there, over 2 plus c. Cool. Right, we've got a bit of time left. We're only halfway through the lecture, so this is good. Bodes well for finishing all this stuff off. So there's 3 left. First one, long division. Second one, partial fractions. And the third one, substitution plus something else. So I want to see if you guys can do these. So last time you needed 18 minutes. I'll give you 15 again and we'll see how you get on. So 15 minutes to try these. Comment if you need any hints. Doing good, guys. Do you need any extra time for question 20? Has anyone got onto 20 yet? Because I'd like for you guys to try it. All right, I will do 4 minutes. Yeah, give it a go. 4 minutes sounds about right. Cool. Right. Do you need more time? No one's commented an answer yet. Do you want slightly longer? I can do like 2 more minutes if you need it. With answers, we'll start going through it, but I'll give you a little bit longer. So we've got long division for the first one. Tried that, must have messed up. That's right, we'll go for it now anyway, done. So long division for the first one. So we're doing x squared minus 5x plus 6 divided by x plus 8. So we get x on top, x squared plus 8x. One take the other. Gives me minus 13x plus 6. Minus 13 up there. We're going to get 104 there. Minus 104. Subtract those. Gives me 110. So we're turning our integral into x take 13 plus 110 over x plus 8. And that's what we need to do an integral of. So x take 13 is going to go to x squared over 2. Take 13x plus 110 then x plus 8. Which is, I think that's what Dan got there. Is that what you got, Dan? Half x squared. Yeah, that is cool. All right, and Kez, you got those two. Good. I'm assuming the rest of you did. You just didn't comment. Okay, 19 is a partial fractions question, which we all love. So x plus 8 over factorize the bottom. X. What's it going to be? 3 and 2 minus 3 minus 2. We get a over x take 3 plus b over x take 2. We're going to get x plus 8 equals a, x minus 2, b 3. Let x equal 2. We get 10 equals minus b, so b minus 10. X equals 3. We get 11 equals a. So my integral becomes the integral of 11 over x take 3 minus 10 over x take 2. Which is going to give me 11 log x take 3 minus 10 log x take 2. And there isn't really anything I can do about that. I can't really combine those because they've got different fractions. Yeah, cool. Right, that's the answer for that one then. Okay, last one then, which is one that was the most difficult. Is this one. So I'm going to say use u equals log x. You can also do this with u equals 1 minus log x, but it's worse. It's way worse. So u is log x. So du by dx is 1 over x. So dx is x du. So the integral will become u 1 minus u over x cubed x du. X there will cancel with the 3 there and give us x squared. So we get integral of u 1 take u over x squared du. All right, we need to change that x squared on the bottom into a function of u. So to do that, I'm going to e both sides. So e to the u equals x. X squared is e to the 2u. So the integral is going to become u 1 minus u over e to the 2u du. Cool. Remembering that we said u is ln x earlier on. So to do this, I'm going to expand the top, bring the e's up. So we're going to get integral u minus u squared times e to the minus 2u. I'm going to expand it to get u e to the minus 2u minus u squared to the minus 2. Okay, so 2 by parts questions basically, one of which, the second one, we're going to have to do twice. So I'm going to split it up into 2 separate integrals. We'll do, again, I think something cancels in this one. So I'm going to do the second integral first. So u is u squared, confusingly. V dash is e to the minus 2u. U dash is 2u. V is minus the half to the 2. So when I put it all together, we get uv minus the integral of v du dx, so it's going to be plus 2u e to the, sorry, the 2 there is going to get cancelled out. It's actually going to be u e to the 2u. Okay, remember all of that is this bit here, so we need a minus there, integral of u e to the minus 2u. So again, you can see if I expand the brackets, that's going to turn into a plus, and that's going to turn into a minus. For the first integral, second integral cancel, so my answer is going to be a half squared e to the 2u. If we go right back to the beginning, u was log x. So we're going to get half log x squared e to the 2u, e to the 2 log x. We can then use the power rule to get half log x all squared e to the log x squared. E and the log will cancel to give me half ln of x all squared times by x squared. Okay, what was your comment there, Sam? Sorry, I wasn't paying attention to the screen when I did that. One of the two u powers is negative and the other positive. Have I made a sign error? Let me rewind the feed. A to the minus 2u. Did I copy this up badly? Just watching what I did. Oh, I do talk a lot, don't I? Ugh. No, I think it's all taken account for. Nope, I have made a sign error. Okie dokie. Yeah, so all the way through there should have been an extra negative in the powers. So that should have been 2. That should have been there. That would make it squared. The actual answer should be 2x. Let's see. Yeah, well spotted there. I did make a sign error. Yeah, they both should have had negative. Both should have had negative powers. But I copied it wrong. I'm watching it back now. Yeah, sorry guys, there should have been a negative power. It's the bit I wrote in red when I wrote the U's and the V's out. I forgot to include the minus when I integrated U. But it kind of, the mistake carries all the way through, and they would still cancel. And our final answer should have that extra minus term, which is part of the power rule for log. Okay. We've got 14 minutes left. Shall we start something else? No, but I do need to ask you guys what you want to do next week, because it turns out we don't have as much time left as I thought. I had planned to do area integration. And vectors. But what would you guys like to do, because we only have 3 lectures left? So what topics would you guys like to do? We finish next Friday, so basically we can cover 3 more topics. I've got stuff planned for these 2, but we don't have to do those. I can do something else if you want. But what would you guys like to focus on? A bit on parametrics. Yeah, there's some parametrics in the area integration, but I can add parametrics on here as well. Anything else you guys would like? It's tough knowing what to really focus on. I thought we had another week, but turns out we don't. If no one else comments, I'll just do these 3. But if you guys particularly want anything else, I know functions was mentioned. If there's any mechanics or stats, well, probably not stats because you can just rewatch the video. If there's any mechanics that you want me to go over. Okay, if vectors is the main one, then that's fine. A few people have said that, so that's totally doable. Right, otherwise, guys, I will we'll end it there for today. And yeah, next week we'll probably start with area integration then vectors, and then parametrics. Yeah, cool. Coming to the end. Crazy. All right, have a good weekend, 3-day weekend. It's going to be good. Separating variables. I'll see if I can fit it in somewhere. What I can do, Dan, if I can't fit it in with this class, I can film the video of separating variables with another class, because my other groups have already done area integration, so they've only got 3 topics left. So there will be a video done for separating variables. I'll do those topics for sure. And then you guys can just watch the extra lecture if you do want to go over that topic as well. I'll probably do it that way. So I'll do those topics. All right, have a nice weekend. I'll see you guys later. Bye.